everybody, and welcome to a new session of our webinar on data science and statistics. Our speaker today is Carlos Soares. Carlos Soares is Associate Professor at the Faculty of Engineering of the University of Porto, where he is Sub-Director of the Department of Informatics Engineering. He's also Director of the PhD Program on Informatics Engineering and Adjunct Director of the Master Program in Data Science and Engineering. Carlos also teaches at Porto Business School, and he has recently joined Fraunhofer Portugal ICOS as Innovation Lead. He is mainly interested on meta-learning and auto-machine learning, but is generally interested in data science. Today, Carlos will speak to us about discovering a taste for the unusual, exceptional models for preference mining. Welcome, Carlos. I'd like also to ask everybody to please switch off your microphones and videos, as we'll be recording the session. Thank you very much. Carlos, the floor is yours.
Okay, Paula, thank you very much. Thank you for having me. It's a weird kind of return home because I've been a teacher at the Faculty of Economics for a long time, but this is not the kind of return I would expect in Zoom. But it's still nice to see some known faces and talk to some friends. I also, Paula asked the audience to turn off the mic, but if you want to interrupt me with questions, please just open the mic because I won't be looking at the chat. So if somebody wants to ask something or say something, just open the mic and please go ahead. Okay, so this is what I'm going to talk about today is actually work done by one of my former students who is currently in Leiden University, Claudio Sá. And this is joint work with Wouter Davestein from Technical University of Eindhoven, Paula Zved from University of Minho, Alípio Jorge from the Faculty of Science, and Arno Knoble also from Leiden. So it's spread all over Portugal and the Netherlands. And this is actually, so as Paula said, my main interest is in meta-learning and AutoML, but this is one of those examples where we've been doing different stuff. And the work that I'll be very briefly introducing today is actually published in 2018 in the Machine Learning Journal, so you have the link here that you can follow. So the idea is what I'm going to present is exceptional models for preference mining. And since one of the examples is about sushi, Claudio came up with this very nice title of Discovering a Taste for the Unusual, which I think fits perfectly what I'm going to talk about. Okay, so I will start by introducing Subgroup Discovery, which is a different kind of descriptive analytics task, and then preference learning, which is a different kind of target variable. And then I'll join the two into the exceptional models for preference mining, and then I'll present a couple of use cases. I'll try to keep it under the 25 minutes, hopefully. So subgroup discovery is somewhat related to outlier detection and anomaly detection. So basically the idea behind subgroup discovery is to find observations that somehow are different from the others. One of the differences to outlier detection and anomaly detection is that usually in these two problems, the idea is to identify specific observations, while here we're looking for groups of observations. And also in this case, the description of those groups is also very important, while in anomaly detection and outlier detection, that's not always the case. Very often identifying the outlying or the anomaly is sufficient. So here we want to understand what is the different behavior. And so it can be described as a data mining framework because it's very much oriented towards extracting knowledge. So this again, the descriptive part, and the idea is to find subsets of a data set where something different is occurring when compared to the whole population. So for instance, in this picture, you can see that in these areas, the terrain is different from the general terrain. So this is the kind of, and it's sort of a small area, even if not too small. Subgroup discovery is also related to pattern mining. And the main difference is the role of a target variable. So usually in pattern mining or the traditional pattern mining tasks, we're just looking for patterns without concern for one specific variable. Things like, for instance, market basket analysis. People buy this product, also buy that product. So finding patterns in the data without concern for one particular variable. In our case, in subgroup discovery, there's always it's a supervised task, so there's one variable which is important. So for instance, in this case, we have a rule where our target variable here is what kind of sushi the person wants, and the description. So the system that analyzed the data found out that people with the age of over 30, they like salmon roe, which is not very popular. So salmon roe, most of the population doesn't like it. So the idea is to have a subgroup, which is people with age greater than 30 that have a different behavior in terms of one particular variable, in this case, what kind of sushi they like. So this is why it's a supervised task. Even if it's essentially a descriptive task, we use it for descriptive goals. So how do we evaluate subgroup discovery? So there are basically two main concepts around evaluation of subgroups. One of them is they must be exceptional, they must be different from the whole population. So there's this notion of distance of the sample of the subgroup in relation to the whole population. But there's also another component to the quality, which is the size, because we want subgroups that are not too small. So they must represent some pattern and not just data noise in the data. So we're looking for patterns for interesting phenomena and not just some random data or some random noise that appears in our data. So these two components are important in the quality of subgroups, which is, they must be different from the population or from the other observations, but it should be a big enough subgroup in order to be interesting, let's say. So this is what I had to say about subgroup discovery. Now let's talk about preference learning. Now preferences, you can find preferences in many problems. You have preferences for movies, you have preferences for food, for wine, even for holiday places. People tend to have opinions and preference regarding everything. And preferences can be represented in many different ways. So for instance, in this case, we have a relationship of preference regarding 4 items, item 1, 2, 3, and 4. It doesn't matter what it is. And the preferences of 4 observations regarding these 4 items are represented, can be represented as ranking. So in this case, this first observation ranks the first item in the 4th position, then the second item in the third position, and then the third item in the first position, and then the fourth item in the second position. So basically, this is a ranking of the 4 items. You can also represent them as an order. So in this case, it would be the same thing to say that the third item is preferred over the fourth item, which is preferred over the second item, which is preferred over the first item. So these are just 2 types of representations. An alternative kind of representation which we have used in this work is pairwise preferences. So for instance, if I have the order, the second item is preferred over the third item, which is preferred over the first item, we can represent these as pairwise preferences. So we say that the second is preferred over the third and is also preferred over the first item. The first item is not preferred when compared to the second item, and it's also not preferred when compared to the third item. Finally, the third item is also not preferred when compared to the second item. So this is basically, these are 2 representations of exactly the same information. Any questions so far? If not, I can move on. So one way of representing these pairwise preferences is numerically by when one item is preferred over the other, we represent that as 1. And when it is the other way around, we represent that as -1. Now, if we're talking about representing, this is a good representation of the preferences of a single person, for instance, regarding sushi. You know, this person prefers the second sushi to the third one, and then to the first one. So this is for a single person. But in subgroups, we want to represent preferences of multiple people of the subgroup. So what we end up having is we have to aggregate these preferences somehow. And in this case, sorry, I forgot to turn off the phone. So in this case, if I want to aggregate these preferences, I can compute one matrix like this for each observation, and then simply compute the average. So for instance, in this case, when I compare the third item to the second item, so this is the number that I have here, basically I look at the 4 matrices that correspond to each one of the 4 observations, and I observe that the third item is always preferred over the second item, so the value is always 1. So this is the 1 times 4 divided by 4. In a different example, so for instance, if I compare, if I aggregate the pairwise preferences between item 4 and item 1, I observe that item 4 is better than item 1, is preferred over item 1 once. So I have 1, 1, 1. But on all the other 3 matrices, the first item is preferred to the fourth item. This is actually wrong, so this should be here to the right. But then this is basically 1 plus 3 times -1 divided by 4, and I get minus 0.5. So we need this because we want to represent preferences, for instance, of sushi, not over a single person, because there might be conflicts, but over a subgroup of people. That's what we're looking for. We're looking at we're searching for subgroups with interesting behavior. So basically now we join the 2 things. So subgroup discovery is about finding subsets of the population, subgroups of a population that behave in a different way from the whole population. And in preference learning, what we're talking about is data where the target variable is not a variable, actually is a ranking of a number of items, like different kinds of sushi, for instance. So what we do is in order to develop exceptional, by the way, there's a sort of a war between the people called subgroup discovery and exceptional model mining. To be honest, I don't even, if you ask Claudio, he can tell you all the minor details of the differences. I don't really care. To be honest, we're basically looking for sub parts of a population which behave different from the whole population. So in this case, Claudio chose the name exceptional models, not subgroup discovery. And then he called them the exceptional models for preference mining, as would be obvious. And so the idea here is I have the matrix that represents the whole population, and I want to find subgroups of this population where the matrix looks very different from the original one. That's essentially what I'm looking for. And I want this matrix to be as different from the matrix corresponding to population, but I want the subgroup. Remember, I want the subgroup to be sufficiently large to be of interest. So there are several ways we can measure the difference. So for instance, I can look at just a single pair of items or a pair of labels. So for instance, in this case, in the whole population, the sushi tamago is preferred over kappamaki. And we have a score of 0.5 saying that. But there's a subgroup, our subgroup, where actually when we compare the two types of sushi in this subpopulation, there's actually a preference for kappamaki in comparison to tamago. So it's in the whole population, people tend to prefer tamago over to kappamaki. In our subpopulation, our subgroup, people tend to prefer kappamaki to tamago. And this is when we focus on a single pair, but we also have criteria for the whole label, for a line here, and we have also criteria for, we can also compare the whole matrix. And I'll show you examples without going into details in a minute. Now, one of the dangers of this kind of approach is that since we're dealing with small groups, all the statistics that we compute, are not very robust. And we look at a lot of subgroups. So we expect a lot of the numbers that we get to not be statistically significant, to be noise rather than patterns. So this is where Wouter came in with, we adapted some work from Wouter Davestein, where in order to deal with these kinds of, let's say, not very robust patterns, or to assess whether the patterns are robust or not, what he uses is he computes does essentially a permutation test. So basically what we do is we randomly shuffle the labels in our data set. We do this, for instance, 100 times. We generate 100 different data sets by completely shuffling the labels. And then we compute the scores for subgroups using each one of those data sets, and we generate a distribution. And if the rule found on the original data, if the subgroup found on the original data has a quality which is significantly higher than these random rules or these random subgroups, then we assume it's really an interesting pattern. So now let's talk about sushi then. Any question about the technique or anything before we go into the sushi?
Tem a ver com valores próprios. Essa questão dos rankings, dos ranks, tem a ver com valores próprios, não?
Nós não estamos a usar nada disso. O que nós fazemos é pura e simplesmente isto. É pegar, calcular. Paula?
Sim, estou a ouvir.
In English, please.
Oh, sorry. So the question was whether we're using eigenvalues or something like that for the processing of the data. No, we're just doing something very simple. It's for every observation we compute these simple matrix is representing the relative, the pairwise preferences, and we do a very simple aggregation for each subgroup. Okay? That actually might be an interesting idea, which we never discussed, but we did something very simple, actually. More simple than that. Any more question? Okay, so let's talk sushi then. So this is data that is actually publicly available, asking people in Japan about preferences about 10 different kinds of sushi. And if I remember right, I think there are 5,000 answers, 5,000 observations. And of course, we have the rankings. This is our target variable, or well, it's not a variable, it's multiple variables, but it's our target, it's the ranking. And then we have lots of social demographic information about the people who answered. And Claudio got some really, I think, really cool results. So this is, remember I told you there are different ways of measuring the interest of a rule, of a subgroup, either by one cell at a time, which is what we call the pairwise case. So in this case, if you look at this cell here, this one represents the preferences of sushi D concerning sushi B. And we observe that sushi D is usually not preferred over sushi B because this color tends to be red. But in a particular subgroup, which is defined by the males who live in Tokyo, but who have lived in Ibaraki, you know, your guess is as good as mine what this means. But those people defined by this subgroup, they tend to prefer this kind of sushi, which is sushi D. So sushi D in this case, it's still not, you know, not the most preferred sushi, but it becomes preferred when compared to sushi of type B. So this is the average, let's say the average ranking that of this group, where we have D preferred over B, which doesn't usually happen in the whole population. So this is the first case where we look at a single pair at the same time, but we can also look for all rows. So we're looking at a label at a time. So in this case, what we have is, in general, sushi E is, you know, people don't have very strong preferences concerning sushi E, unless when compared to sushi H, where they prefer sushi H over sushi E, and they tend to like sushi E when compared to sushi J. But then there's a group of people where people who live in Kwanto, Shizuoka, and they used to live in Hokkaido, and their age is above 3.0, which is I guess normalized age or a normalized code. This should be an age group which I don't remember. And in this case, people strongly prefer sushi of type E when compared to all the sushis. So here you can see there's not a strong preference. In this case, they actually don't like it very much when compared to this one. They prefer H over E, and they tend to prefer only E when compared to J. But in this particular subpopulation, they really, really like sushi E. So this is what we call the label-wise patterns. And then we have the ranking-wise patterns where we compare the whole matrix. So for instance, in this case, we found, you know, this is not as easy to see as you can imagine, but in this case, we see here some patterns which are a little bit more, you know, this is the whole population where most of the patterns are not very strong, but here we see some colors which stand out a little bit, which means that people have preference for these kinds of sushis. And this case is the case of people that live in Eastern Japan and used to live in Ibaraki, and they're aged, so they are young. And they have a preference ranking which is different from the others. So what's, in this case, there was one pattern which is really very obvious, and Claudio looked into it carefully, and he found out that it relates to this sea urchin sushi, which, if you look at the whole population, people tend not to like it, but in this group, you know, they really tend to like it. So the technique was able to help us find some behaviors which are, you know, they represent a significant part of the population. So these are groups that represent a significant part of the population, and they have a behavior which is different from the population, and thus it's considered interesting. I'll go quickly through another example. So this is we can look at elections also as preferences. If you look at the final results of the ranking of the political parties or the candidates, and we looked at data from a federal election in Germany in 2009, where we have several indicators, several variables. And here you can see this is the distribution of votes for the left party in general. So this is the blue. This is the distribution of votes. So people tend not to vote. So this means that it wins the election, and this is the last party. So the left party tends to lose elections, but if you look at East Germany, they have a stronger position. And in this case, it has to do with income, where apparently left parties are also they have very low votes in groups with higher incomes. And then some other patterns that we were able to obtain. So, for instance, the Green Party, which is usually also has a bad result on average in the whole population, tends to be better in Bavaria, but not that much better. On the other hand, the left party, which is also one of the worst ones, the left party tends to have good results in some places, and SPD also in Brandenburg also has a better position than in the other countries. We did something similar for movies, just to finish. We had something similar with movie preferences, where we use data from a public data set, MovieLens. We have ratings from users concerning a number of movies, and then we also have some characteristics about the viewers. And you know, this is the whole population. You can see here, you know, also the colors are not very strong. But then we found a group here of people aged over 34 years old, where you can see a few patterns, a few colors which are more alive. And this tells us that the people with an age bigger than 34, they tend not to like American Beauty. They tend to like Star Wars: A New Hope more than the rest of the population, even though the trend here is not very strong. They tend to like also Saving Private Ryan, especially when compared with American Beauty. The color here really becomes very strong. And the last one, they tend to like Jurassic Park more than the rest of the population, which I think makes sense because, you know, younger people have seen movies with much better visual effects than Jurassic Park. But for the rest of us, for the older ones, you know, that was really a groundbreaking movie. Okay, and so that's it. If you want to try discovery tools, Cortana is a tool that was developed in Leiden that has some of these methods. Also, Martin Atzmüller, who is currently, I think, in Tilburg, also has a R package for subgroups. I think the package from Paulo Azevedo, I think the version which is available in CRAN also for R, also contains subgroup discovery for rankings. So there are several tools you can try for this. And with this, I finish. I'll take the easy questions, but if you have tougher questions, you can ask Claudio, of course. Now you can ask them to me, and if I don't know, I'll redirect you to Claudio. So thank you very much.